This is a Mallett Technology Tech Tip, a Mallett Technology Tech Tip. This tech tip is extracting nodal forces, or more commonly, retrieving weld forces. Scott, the screen is yours.
Thank you. Okay, so we have a lot of customers that are interested in extracting the forces from a weld for further analysis. So there are many different methods to extracting this information. We have here is a simple shell model, which has just a couple of rectangular bars running down the side and across, and then there are 3 plates that are welded to the top. So in this method, what we have is we have a contact for each one of these parts, basically lined to surface contacts. We've got bonded contact along the edge of each one of these plates. And then we also have a bunch of bonded contact between the edges of each cross member to the main member. And as you can see here, I've kind of got them broken up into sections. But you can see that I've got contact from that edge of the beam to the surface of the other beam. So I've got a handful of bonded contacts here that bond these plates to the sort of supporting frame, if you will. And if we take a closer look, you can see the setup of this. And what we're going to do is we're going to imagine that there's a weld along the edge of this plate, and we're going to extract the nodal forces that we would get out of that weld, which you would then take to your hand calculations or a spreadsheet or something like that to determine whether or not the welds will be substantial enough. So it's a very simple model. I've got it fixed on the ends all the way around, and we've just got a load coming through this bolted plate, if you will. And we've got a deformation, and if we want to, we can actually query that contact surface in there and see what's going on from sort of a global perspective, if you will. But a lot of times what you might want to do is extract the forces at each one of those nodes to make sure your welds are substantial enough down the edge of this thing. So we're going to show a method for creating that or extracting that information from the model. So this is a real simple process. I'm going to grab that edge where the part would be welded, where that contact pair is. I'm going to right click, and I'm going to create a name selection. In this case, I'm going to call it Weld Edge. I'm going to use that contact pair then to query the results in there. Now there's a simple way to do this. I'm going to open up the worksheet. So I click on Solution, open up the worksheet, and I'm going to look down through the list of available quantities that we can grab out of here. And one of the quantities that we have access to, we can dig it up in here, are the vector forces on those nodes. So I'm just going to right click and create a user-defined result. I'm going to go into that user-defined result, change my scoping, name selection, weld edge. We'll look at the top section there. I'll evaluate my results. I'll adjust that to the visible portion only, and we'll see that we have those weld values at each one of those nodal locations on the plate. Now what we can do with these now is we can export them, and we can export them directly to Excel. So we right click and say export. I already have a file, so I'm going to replace my existing file. And what you see here is we've got the node numbers listed, and then we've got the force vectors listed here as well. Now we can extract these independently if we want separate X, Y, and Z values in a spreadsheet. We've got that information here. Or if you want to use them for further calculations, you can actually come in here and do the same process. And down inside of there we have also the X, Y, and Z only directions. So if you're looking for specific directions, otherwise we can get all the information we need from the force vector section here as well. And that concludes our Mallett technology tip for extracting weld forces.